Hello everyone, this is Diana. For today, I'm going to introduce you about the mechanical energy storage. Remember that I mentioned in the previous slide that I'm going to explain the energy storage technologies according to different classes or different categories. So one of the categories is mechanically operated. So yeah, enjoy the slide. So this is the lecture structure, which I will try to cover between 45 to 60 minutes. I believe that it's quite comprehensive for this one. So it will be five technologies that will be covered under this topic. And of course, each of it will be discussed or will be explained in quite detail. I also provide some general terminology and also the method of operation of this the system mechanically, and also some references and additional terms just for you to refer to. Okay, I'll start with the terminology, general terminology of mechanical energy storage. I took a reference from the Energy Storage Association, which says that the system exploits kinetic or gravitational force to store the inputted energy. Physically, of course, mechanical systems are quite simple, such as you spin a wheel, or you can just lift up a weight to somewhere higher. But of course, because we have advanced computer that can control the systems, we also have high-tech materials, and of course some system can be innovatively designed, which makes the mechanical energy storage more feasible, more flexible, and can be effectively used in this real-world application. Now we move to the general mechanism behind the mechanical energy storage. So I took references from NETL, National Energy Technology Laboratory, and also from the Southwest Research Institute, which they mention that mechanically the energy will be stored by applying force to an appropriate medium to deliver acceleration, compression, or displacement. And the process can be reversed to recover the stored kinetic or this potential energy. And the system also works in a complex system which use heat, the water, the air with compressors, turbines, and other kind of machinery. I also refer to one published paper in 2020, which categorized mechanical energy storage into two. One should be purely mechanical, and another one should be combined with electrical. So the main difference between these two, definitely the one that combined with the electrical can be able to transmit or transfer the stored kinetic energy into electric through the use of motor generator. So the first mechanical energy storage technology that I'm going to start with is flywheel energy storage, FES. So I'm going to touch on the principle behind this technology, the components, the mathematical equation, the energy power density of this technology, the system performance, some advanced findings, and also the application. So we're going to understand a bit the principle of flywheel. Of course, flywheel stores energy by taking the form of a kinetic energy from the rotation inside the flywheel until the rotates are accelerated, and then the electrical energy will be transferred to the stored kinetic energy, and this will happen during the off-peak hour or during the low energy demand. And this process will be vice versa. Whenever we want to use the stored energy, definitely the stored kinetic energy will be transferred back to the motor generator. That is when the electricity will be generated. So the energy density or the stored energy density of flywheel will be depending on the angular velocity of the system, while the energy can be lost depending on the air resistance or also wind shear. And it's very important that the material of flywheel should be very, very strong because of the high pressure created from the rotation of the flywheel. And a vacuum environment should be maintained to ensure that the performance and the efficiency of the system is retained or increased. And now we get to the components behind the flywheel. Of course, it consists of three main parts. So the first one is a cylindrical part, the rotor, the flywheel rotor, which should be solid and also in large mass. The second one is the magnetic suspension. You can see that the bearings, the support bearings here, which support the whole system inside this flywheel chamber, which it functions to reduce the mechanical wear that happens in between. And we also have the other complementary part, which includes the power electronic units, which to power the reversible motor generator. And then we also have the vacuum chamber, this one, and the vacuum pump. The motor generators, of course, in order to transmit the electricity to the rotor and also to generate electricity. The other one is the casing, the outside casing, to provide the vacuum environment and also to contain the other parts of it. So I'll play a short video that shows how we can operate the flywheel. So that is the solid cylinder, which create the rotation, will spin according to the speeds. And of course, we requires a very strong casing that should be strong enough to withstand the huge force inside it. And we also have the motor and the generator, that should be connected to the flywheel rotor, and the bearing, the bearing which be able to reduce the mechanical wear. And we also have the vacuum chamber and the vacuum pump, which helps to remove the air from the chamber, which these can reduce the air resistance, and of course it will increase the efficiency of the system. So this is the mathematical equation behind a basic electric flywheel, which of course we know that the energy will be stored kinetically by the rotation of the rotor inside the flywheel. To calculate E, definitely is depending on the moment of inertia of the flywheel and also the rotational speed. I will definitely explain on I later on. To calculate the moment of inertia, it will be depending on the inertial constant, which is subject to the shape of the flywheel, and yes, it is unitless, and also the mass of the flywheel. Remember that the flywheel rotor should be solid and should be in like large mass, and also the radius of the flywheel. So these just some examples of the shapes of flywheel and the shape factor K, which this one will determine the moment of inertia of the system. It will count from 0 to 1. So basically, if you see the level D has the shape factor of 1, while the bottom one, the thick rim, it has about 0.3. So the flywheel systems are categorized into high-speed system and also the low-speed system. For high-speed flywheel, it generally can speed up to 1 million RPM, and the specific energy density can be achieved up to 100 watt-hour per kg. While for the low speed, it generally speed up to 6,000 RPM, and the specific energy density of 6 watt-hour per kg. So this is the system performance of flywheel. In terms of the advantages, of course, the system can have the efficiency more than 90%. I mean, of course, depending on which application that the system is used. It has high power density and energy density. It has long operating life and low maintenance costs. and it requires very low for natural conditions. Well, the system also has challenges. The device can perform quite poorly at stop rate, which this results in excessive self-discharge, and it has the incapability for long duration storage because of the existence of the friction. Remember that the air resistance is the one that can increase the loss of the energy. Some advanced findings on the flywheel. Remember that we have learned that the rotors that are made for the flywheel should be in solid and also should be in huge mass because that will determine the speed of the flywheel. So conventional material that they use to make the rotors are metal, but of course in the advanced findings and trying to make replace the metal rotors with the composite rotors, where the composite rotors, of course, they try to mix the metal with different materials such as carbon fiber, carbon nanomaterials. Of course, this one will help in terms of improving or increasing the speed of the flywheel. There's another findings on flywheel. They try to use better materials for the bearing part, where one of the examples they try to use high temperature superconducting, which these will help in terms of reducing the support idling loss, and of course to reduce the self-discharge of the energy from the flywheel. But of course, when we use HTS, it requires low temperature cooling process. One of the materials that can be able to reduce this is to use liquid nitrogen, which will, of course, reduce the temperature up to negative. But of course, this one will increase the capital cost of building the flywheel. And another one is trying to introduce is the use of non-contact bearing, which helps in reducing the friction. So I'm going to touch a bit on the application, just show you some examples. Of course, in terms of the application, depends on which flywheel that you are referring to. So if you want to use a high-speed flywheel, definitely it's more feasible for large-scale applications such as aerospace services, the traction, like railways and stuff like that. For low-speed FES, it's more feasible to apply it for small to medium scales application, such as you can integrate flywheel with the microgrid energy system. And also, for example, you want to apply it for residential, where the flywheel is flexible enough to be integrated to the PV panel, where the PV, of course, it helps in terms of generating the energy, and the energy generated based on the PV can be connected to the flywheel, where definitely the energy can be stored kinetically. And then whenever we want to use the flywheel energy, definitely it can be transferred or transmit back to the motor generator, then we can use the energy. So now we'll move to pump hydro energy storage system. Pump hydro system has aged more than a century, which it has the function to balance the load in the electricity industry. This system, the storage plant is commonly in large scale, where each project can store more than 100 megawatts energy. So to understand the operating principle of the pump hydro system will be much easier to understand how the system works during charging and discharging. The system will charge or store the energy when there is excess power generation. So the electricity will be supplied to the motor and the turbines, and the water will be pumped up to the upper reservoir from the lower reservoir. This will cause the energy to be stored kinetically. So while the system will be charged or the energy will be released, it's actually during the high electricity demand. Therefore, the water which is kept at the upper reservoir will be released downhill to the lower reservoir. and the water pressure and also the speed of the water will spin the turbine or the rotor, which then will generate the electricity through this generator. So if you can refer to both of the gifts that I have put here, they are very, very good examples to understand the system works during the low energy demand versus during high energy demand. So during low energy demand, excessive power capacity assists to pump up the water from the low to higher reservoir, and the energy is stored in the form of hydraulic potential energy. So during high energy demand, of course, you have to think vice versa, where the water will be released from the upper to lower reservoir, and it will go through the reversible turbine or rotor to generate the electricity. If you can refer to the figure on the left side, definitely you can really understand what are the main components that are built for this system. Of course, the first thing first, you will still need to have two reservoirs. One will be located at the lower part and another one will be located at the upper part. Of course, the lower reservoir is where the water will be kept here, and then where the water will be pumped up to the upper reservoir to store the energy via hydraulic force. And then whenever we want to discharge the energy, definitely the water from the upper reservoir will be released downhill and will go through the turbine. And of course, we need to have the closed tunnel where it should connect the upper reservoir to the turbine and also to the lower reservoir. And then of course we need to have the whole system where it should function as the to pump the water and also to generate the electricity. So we need to have the pump station, and then of course we need to have the reversible turbine where it should spin to power the generation, and then it should spin to pump the water from the lower reservoir to upper reservoir. And then the motor generator unit, of course, it should be combined or connected to the turbine, where whenever we want to release the energy, so the pressure and also the speed of the water will spin the turbine, and this one will also spin the generator. That's when the electricity will be generated. And this one will be connected to the transmission lines and to the power grid. And also we need to have the control valves here. Of course, it functions to control the water in terms of the pressure. Some system they control in terms of the temperature and also the water speed. There is no much different to compare between the pump hydro system with the hydroelectric generator system, where both systems have used the water pressure from the water intake to generate the electricity by spinning the turbines. It's just that the main function of the hydroelectric is solely to generate the electricity, and the system stores the energy by depending on the volumes of the cap water, such as at the water catchment or dam. So the same as the pump hydro, definitely the water will be transported from the water intake to the turbine, and of course we need to have the penstock or the closed channel which connect the dam to the turbine, and the water, of course, the pressure from the water will spin the turbine and the generator, and that's when the electricity will be generated and will go to the transmission line and will go to the national grid. So the system has, of course, it has its advantages. The main one should be the efficiency of the system, which around 90%. And if we can sufficiently provide large water reservoir, definitely the system can generate gigawatt hour of energy. But of course, it has its disadvantages as well. It's geographically dependent, so it depends on the size of the water volumes, whether it is like a large river or dam. And the built system is not very efficient in energy storage. About 10% of the energy stored in the upper reservoir will be lost when the water passes through the turbine. So to understand how we can actually store the energy using the system, definitely we have to refer to the gravitational potential energy equation. Remember that whenever we want to store the energy, definitely we have to pump up the water up to the upper reservoir. So the amount of stored energy is proportional to the height difference between the reservoirs and the mass of the water stored. So the E will be account for gravitational potential energy in joule, and M should be the mass of the water stored in the upper reservoir in kg, and G definitely is Earth gravitational force, and H will be the height difference between the upper reservoir and also the lower reservoir. And then to calculate the M, it should be equal to rho times V. The rho will be the density of the stored water in the reservoir, and V will be the water volume stored in the upper reservoir. Now we go to the energy and power density of the system. So the pump hydro system, it has the efficiency between 70 to 85% per site, and its overall power capacity between 1 to 1.5 gigawatt per site. Now we'll go to the system performance. We'll start with the ideal features. Number one is the altitude within the reservoirs. The higher the altitudes between the upper and also the low reservoirs, definitely will give a better feature to the system. And then we have learned that the system has the efficiency between 70 to 85%. Definitely it will give you higher power potential and large rated capacity. Favorable geographical environments, of course, if you have large water catchment, it will give you a better feature and better performance. And if it is close to transmission lines, which of course is easier to transmit the generated electricity. In terms of the advantage, it has high speed capability, of course, because it depends on the pressure of water goes downhill from the upper reservoir to the lower reservoir. It has long life cycle period, and of course low operation and maintenance costs. In terms of the challenges, geographical constraints, almost similar with the hydroelectric system. Massive large scale of the unit and high capital costs. One of the very interesting findings which I found on the pump hydro system is there is an attempt to downsize the system by introducing the use of high density liquid, where this liquid it will replace the normal water, and the scale of the installation hose can be downsized from installing at the high hills to smaller hills. So this company, Reenergys Limited, which is based in the UK, it proposed and invented high density hydro R19, which its density is 2.5 times denser than water, and of course in terms of the power density it can generate 2.5 times better than the conventional system. In terms of the applications, pump hydro energy storage system plays a very important role in leveling other power generation plants and try to stabilize the power grid. And of course, the system adjusts the demand supply to balance and to reduce the gap between the peak and the off-peak periods. Now let's move to compressed air energy storage system, or we can short form it as CAES. So if you can refer to the figure at the right side, you can see an underground reservoir, or we can consider it is a cavern, is used for compressed air energy storage system. So during the charging, the CAES stores the energy by pressuring and compressing the air into a special container or a reservoir when they have the high power cycles and also during the low energy demand. While the system, it discharges and generates the energy by expanding the air from the cavern, and it goes through an air turbine which is attached to electric generators, and that's when the electricity will be generated. CAES is reported to be second after pump hydro in terms of the energy density. And a little history on the system, which is in 1978. Germany has built its first large-scale CAES plant, where it has the capability to circulate about 290 megawatts of power of about 2 hours a day after the air was compressed in 8 hours. And then the latest one, which is in 2020, we can refer to two large-scale CAS power plants in Texas and also in San Joaquin, where the capacity each is around 200 megawatts. Now we can look at a video of how CAS is operated. First, we need a motor to drive the compressors, and the compressors will compress the air to become very high pressure and cool air before it can be kept or stored inside a cabin. Just note that the electrical energy, which is generated based on the motor, will be transformed into potential energy, which will be kept inside the cabin. So whenever we want to use the stored energy from the compressed air, the air should go through a heat exchanger, and that is when the air is expanded and will push or spin the turbine to generate the electricity. If you can see the figure on the left side, we can understand very easily of the basic components built for the CAS. As you know that the energy is stored via pressurization, definitely we require air compressors to pressurize and compress the air into highly pressured cool air. Then we need a cabin or an underground reservoir which to keep the compressed air. We also need an electric motor which to drive the compressors, and a generator which is required to generate the electricity. Of course, the generator will be connected to a turbine. So the spinning turbine will spin the generator from the air expansion, and we also need the heat exchangers, which is used to expand the compressed air, and of course it will change or increase the heat capacity and the temperature of the air as well. As we have learned from the previous slide, the air compression causes the air to be cooler, which is caused by the heat production or heat release from the air. And vice versa, the air expansion has caused the high pressured cool air to be expanded by injecting the heat to the cool air, which then caused the cool air change to hot air. That means the CAS system has to deal with the heat production and also heat injection. And there are three ways to deal with this operation. Number one is through the adiabatic system, and number two, which is through the diabatic, and also number three is isothermal. We will start with the diabatic CAS. So diabatic CAS is actually the traditional way of the CAS system. This system is a hybrid system composed of natural gas combustors that use the highly compressed gas to enhance the combustion process. So during the operation, excess electricity is used to compress the air into a cabin, of course located underground, typically at the depth of 500 to 800 meters and under the pressure of up to 100 bars. Where the stored energy is quiet, the air is released and heated by combustion of fuels or gas and is expanded to power a turbine, which then generates the electricity. Next we go to adiabatic CAS. So adiabatic CAS systems are designed to store the heat during the compression stage. These energy storage systems are designed opting to use and not use thermal energy storage device. So the system without the thermal energy storage, it uses the temperature which is generated from the compressed air, and the hot air is then kept inside an enclosure, while the system with the energy storage, thermal energy storage system, is designed for the recovery and the storage of heat. The stored heat is later utilized during the expansion, and then the elimination of heat from the airstream leads to higher final pressures, which results in higher energy densities. Then we go to isothermal CAS, which is still under development, and it requires specialized machine to handle the heat exchange. The temperature rise of the compressed air is assumed to rise in quasi-equilibrium steps where the heat is transferred almost instantly, thereby preventing the compression process temperature rise and expansion process temperature drop. Once the power is required, the isothermal system uses electrical energy to reach the required temperature, which means that no combustion is required, and this approach is much greener as compared to the other two systems. So in general, the CES has the energy capacity between 50 to 300 megawatts, but of course it depends on which type of CAS system is used. We go to the adiabatic CAS, which it has the power capacity up to 100 megawatts, while the energy density, it has a range between 100 megawatts hour to 10 gigawatts hour. In terms of the discharge times, it's from hours to 10 hours, while the life duration is more than 30 years. The reaction time is very quick, which is in minutes, and the efficiency of the system is more than 70%. Yes, the capital expenditure in power is quite high, between 1,200 to 2,000 per kilowatt. For the diabetic CES, it's almost the same with the adiabatic CES, which the power capacity can be up to 100 megawatts. The energy density, the same, range between 100 megawatt hour to 10 gigawatt hours. The discharge time is almost the same, from hours to 10 hours. The life duration is more than 30 years. The reaction time, which is in minutes. However, the efficiency of this system is 55%. The capital expenditure in the energy is about 50 to 150 per kilowatt hour, while the capital expenditure in power between 400 to 1,200 per kilowatt. For the isothermal CAS, there's not much report on this, but it is reported that the round-trip efficiency is between 70 to 80%. Now we go to the system performance. We'll start with the ideal features. Low pressure environment is actually feasible for this technology because the air is actually the main medium. If we have the suitable geographical sites such as the depleted gas or oil well, salt mine, porous rocks, and cavern reservoirs can also be a storage cavern. Due to this, more sites available for compressed air energy storage as compared to the sites available for pumped hydro. Of course, another one is gas storage locations, which are potentially used as compressed air storage sites. The system advantage of it, it has long energy storage time, which is more than 1 year, with short response time, which is less than 10 minutes. It has good part load performance with high efficiency between 70 to 80%, and it has long life cycle time, about 40 years. It has low environmental effects, and it has flexible capacity range. Of course, the system has a little challenge. Large CES can be quite challenging in managing the thermal energy, since the compression of air can lead to unwanted temperature rise, which this can, of course, can reduce the operational efficiency, and it can lead to the damage to the whole system. And to find the suitable geographic location can also be challenging for CAS. And it is only economically feasible for power plants with rock mines, salt caves, and aquifers or depleted gas fields nearby, which these may lead to higher capital costs. Now we can move to some very interesting findings in terms of making the CAS more efficient.
Remember that we learned about the system has to deal with the heat production and the heat release of the air. So there are initiatives on recovering the waste heat by using it to increase the rate of utilizing the renewable energy. Also, there are attempts to downsize the large-scale CAS to a smaller scale one, which small-scale CAS can be able to replace such as batteries, supercapacitors, because it has several advantages. Which is it has longer lifespan, it also has low number of maintenance required, and it can perform better in worse environmental conditions. Another promising technology derived from the CES is liquid air energy storage system, or in short form we call it LAES, where it can replace the air by proposing the use of liquid air, which is much denser, and it can prolong the energy storage more than the air. So the conventional adiabatic CES, as we learn, which is normally used without the thermal energy storage system, has been researched to integrate the adiabatic CES with a thermal energy storage, where the heat from the air expansion will be absorbed and will be kept inside the storage, and later on it will be used to expand the air and generate electricity. This new way of adiabatic CES, it eliminates the combustion process during the air expansion. The next finding is to integrate the advantage of the LAES and also the thermal energy storage adiabatic CES, where it uses liquid air to replace the normal air, which the liquid air has higher density than the normal air and it can store energy in longer lifespan, while the thermal efficiency is improved by improving the efficiency of compressors and also the heat exchangers. Next, we will learn about gravity energy storage system. As we have learned from the pump hydro system, which can be a bit challenging to install, as the pump hydro mechanism is feasible with certain geographical locations, there are another advanced solution which it applies quite similar gravitational potential energy, but this time it introduced the energy storage based on the displacement of suspended mass from upper point to the lower point. So the gravitational energy storage system, it imitates the reliability benefits of pump hydro, but this time it doesn't limit the technology installation methods. So some technologies it prefers to this mechanical solution over battery storage because the electrochemical solution can be a bit thorough in terms of the environmental effect, and also the safety measures to handle the batteries can be a bit troublesome, and it's also hard to achieve a full lifetime of the batteries as it is claimed. This system, the GES, should be suitably designed with low build and maintenance costs, but at the same time, GES should deliver a great amount of energy. In this part, I will show you three different technologies which use the similar fundamental of storing the energy by gravitational force. These technologies are compared according to three different companies. So the first company is Gravity Power, which it uses a bored hole as a way to store and generate the energy. Another company is ARES, which it uses rails and cars by pushing the cars up and release the cars downhill. Another company is called Energy Bolts, which use suspended cables to lift up and release down the massive bricks. We will start with the bored hole GES, which is introduced by Gravity Power. So these are the basic components that are needed to operate the system. So we need to have a large massive piston, which is kept inside a storage shaft, and there will be water added inside the shaft, and there should be a cap to make sure that the whole system is concealed, and of course the water density will not be changed, and it should be connected to a pump combined with turbine here, and we have a penstock or a closed loop channel which is connected to the ground shaft. So how we can operate it, so you can see from the GIF. So whenever we want to charge the energy, so the electricity will charge the pump or turbine. So that's when the water will go through the penstock and will lift up the piston, and that is when the energy will be stored via gravity force. And whenever we want to discharge the energy or release the energy from the piston, then the piston will drop by gravity and will force the water up to the penstock, and it will go through the turbine, and that's when the turbine will spin the generator and the electricity will be produced and will be connected to the main grid. So it is claimed that the system, in terms of the energy density, it can generate thousands of megawatt hours for each plant. Next, we go to Rail GES, which is proposed by Advanced Rail Energy Storage, or RES, a company in North America. So their system is patented under the name of Gravity Line, which Gravity Line use rail tracks and also rail cars to harness the power. And the system claims to be able to generate up to the main grid power scale with 40 years of service life and without the terminal resistance. To charge the energy, the motor will drive the mass cars uphill, which then it converts the electric power to mechanical potential energy, while the energy discharged from the system is by moving the mass cars downhill, which then it delivers the electric power to the grid. Now we go to the suspended cable tower GES. This technology is proposed by Energy Box, which consists of a tower that is used to raise 35-ton bricks up and down. So the energy charging is by lifting up the bricks, and the potential energy is stored in the form of elevation gain, while the energy discharging is when the bricks are lowered. So this company, it claims that the materials made for the bricks are local source, such as soil, sand and waste materials, which are very important to reduce the capital cost which is spent for the system. To understand how much energy can be stored, we can refer to the equation which calculates the gravitational potential energy, which this energy depends on the mass of the lifting materials and the height difference between the upper points and the lower points. So here you can see the E is equivalent to ml times G times H. So the E is the gravitational potential energy, will be in the unit of joule, and then ml is the total mass of the lifting materials in kg, and G is the gravitational constant, which is 9.8 meter per second power 2, and H will be the height difference between the center of mass in the charge and discharge configuration. To calculate the power capacity or the release power from the GES system, you just have to change the E to P, and the main components, of course, will be depend on the mass of the lifting materials and also to the velocity, which is created based on the lifting material down to the lower points. So the P is equivalent to MB times G times V. So the P is the power capacity, which is in the unit of watts. The MB will be the total mass of the lifting materials in kg, and the G is the gravitational constant, which is 9.8, and the V is the velocity of the lifting system or the lifting material down to the lower point, which is in ms. So now I will try to compare the energy and power density between the three technologies that are being presented before. We will start with the gravity power, which use bolt hole system. So the minimum power density that can be discharged from the system is about 200 megawatts for 8 hours and 16 hours discharging time. And the maximum that it can go is about 800 megawatts for 4 hours discharging time. So the return energy to the grid at about 6.5 cents per kilowatt hour, which is less than 50% of the cost of using lithium ion, and this includes the cost of the energy loss in the round trip. For the RS system, which use the rail tracks, this is made of multiple megawatt hour tracks and can be in various size from 5 megawatt to 1 gigawatt of power. Of course, it has more variety in terms of the range of energy density, which this depends on the weight and also the number of mass cars, the slope and also the distance. In terms of duration, The duration of charging and discharging is between 15 minutes and 10 hours. For the energy vaults, which use the lifting the suspended mass, so each brick represents about 1 megawatt of potential energy to be discharged, and the capacity range between 20 to 35 to 80 megawatt hour storage capacity, and between 4 to 8 megawatt of continuous power discharge for between 8 to 16 hours of discharging time. To make the GES system is more feasible than the pump hydro system, the driven factor is mainly to the control of the initial capital expenditure, which can be determined based on the mass type, the elevation gain, and the mechanism that is used to move and store the mass. Now we will compare the system performance between the three GES technologies that we have discussed. We will start with the gravity power, which introduced the botthole GES. The ideal features are the system can use recycled materials, especially construction waste, which can be a liability because of its high disposal costs. Therefore, by recycling the materials and reuse to build the suspended piston, the cost of purchasing the solid materials can be reduced. The next one is there will be no additional cost to add for the water since the water density is retained. And the system advantage of this type of GS as compared to the pump hydro system is it has much lower capital costs. Then we go to the ARES system, which use the gravitational force based on the rail tracks and mass cars. The good features are there will be no additional reservoirs required as the lifting materials are used instead of water, which means the system has more flexibility in selecting the installation site. The advantage, it has large storage capacities with a fixed or downside system design, and the rolling resistance which is installed on the steel rails are made to be frictionless. The system challenges, it requires grading land and laying tracks, where this can cost a huge amount of the initial capital costs. Then we move to the energy vaults, which introduce the suspended cable GES system. In terms of the ideal features, almost the same with the RES. It doesn't require additional reservoirs and will be more flexible in the site selection. And the efficiency of the system was reported to be about 90%. Now we will move to the buoyancy energy storage system. So, buoyancy energy storage system can be understood by a gravitational energy storage concept. It's quite similar to the pump hydro system, but this time it depends on the buoyancy of a material used to store and release the energy. So the best location to install the system is the deep sea, and it is reported it is more applicable to both storage of offshore wind power and also compressed hydrogen. From the figures on the right side, you can see that the electricity will power a motor, which will lower the compressed gas recipient, which is this object, deep into the sea. And whenever we want to use the stored energy, then the compressed gas recipient will rise up back to the surface by the act of the buoyancy, and this force will then generate the electricity. So the figure on the left side shows the main components required to build this system. So the main one should be the anchor, where it will be connected to a motor and a high tensile strand cables, where a pulley system will be applied here. And the anchor should be able to tolerate the high buoyancy force created by the storage recipient. Then we also need a buoyancy recipient, where the inner medium should be a compressed gas. Usually it's a low density type such as air or hydrogen, and should have a lower density than the water to create the buoyancy force. And the container used to keep this gas can be a series of tanks or balloons. Then we need high tensile strand cables, which pulleys are used here, a motor generator, and also transmission line system that connects to the motor generator to the offshore wind power plants. To calculate the energy storage capacity based on the buoyancy system, we will refer to the governing equation of buoyancy potential energy, which depends on the fluid volume, the water depth, and also the fluid drag characteristics. We will have to use a force balance equation of a submerged fluid based on the following expression. And based on the previous force balance of the buoyancy, acting over a distance which is equal to the water depth, Z, then it will be used to calculate the E, the energy. To calculate the power, the force balance of the buoyancy will act on the fluid velocity, which is U. Since this technology can be considered very recently proposed, from the analytical results, the buoyancy energy storage system is reported can offer up to gigawatt-hour of energy or power capacity. The ideal features of the system include its scale can be diverse from small to large scale use, and the main system elements are abundant, where we need seawater, which acts to sink and float the recipient, and we need compressed gas, such as air or hydrogen, as the inner medium of the recipient. For further reading, you can always refer to the published materials I have provided here and here as well, and some recommended websites too, where you definitely can learn more about the mechanical energy storage technologies as we have just learned today. And of course, you will get a clearer view of how energy can be operated mechanically. I also provide some YouTube videos too here, so you can always refer to this, and some additional terms. And thank you very much for your attention. We'll continue with the next topic on the next slide. Bye bye.